Pluto is a distant and bizarre planet that was once a part of our planetary family. However, recent startling statements by leading astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight with a shocking revelation. They suggest that this freezing world is on a possible collision course with Neptune. Yet, how could this happen? And what may be the results of such an enormous event? Are we seeing an intergalactic catastrophe? Or is there something else to this coming immense impact? Join us as we examine the likely results of a Pluto-Neptune impact. Pluto, a former planet that was downgraded to a dwarf planet partly due to its curious orbit, remains a subject of interest and study in the cosmic community. According to recent assumptions by leading analysts, Pluto's orbit is dangerously close to Neptune's. Astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising the alarm about a possible hazardous collision between these two planets, which could pose a giant risk to Earth. How is such an event even possible? Pluto's journey around the Sun isn't like that of any other planet in our solar system. It takes a shocking 248 years to complete a single orbit. Since its discovery in 1930, it hasn't even finished one full revolution. However, the interest doesn't stop there. Pluto's orbit is marked by its highly elliptical shape, deviating dramatically from the nearby circular orbits of the major planets. What makes Pluto's orbit even more unusual is its inclination, tilted at 17 degrees to the ecliptic plane. The way Pluto follows its path is much more extreme compared to other planets. This inclination and erratic behavior add layers of complexity to its orbital pattern. One of the most fascinating aspects of Pluto's orbit is its intersection point with Neptune's orbit. For around 20 years in each orbit, Pluto actually draws closer to the Sun than Neptune, testing what we could expect from their positions in the nearby planetary system. This leads to the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational effects of other planets. The study of Pluto's orbit began shortly after its discovery. Initially, astronomers tried to figure out its peculiar orbit. Unlike other planets, whose orbits lie fairly close to the ecliptic plane, Pluto's path stuck out with its steep inclination and elongated shape. The mystery grew with the realization that Pluto's orbit does, in fact, cross Neptune's. The stability of Pluto's orbit amidst these complexities is proof of the intricacies of celestial mechanics. The three-body problem in space involves understanding how three objects in space, like Pluto, Neptune, and the Sun, move and affect each other with their gravity. It's like trying to predict where they will go based on where they start and how they pull on one another. For Pluto's case, this problem shows how its orbit, Neptune's orbit, and the Sun's gravity all work together in a complex way. The terms libration and VSK wobbling are part of this puzzle. According to astrophysicists, what's keeping all planets in their orbits is a type of libration with respect to Pluto and Neptune. This term means that when Pluto crosses Neptune's orbit, it's positioned no less than 90 degrees away from Neptune. This spatial separation is crucial in preventing their paths from meeting. Libration, on the other hand, refers to the vertical movement of a celestial body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other massive planet, it's arranged entirely above their orbital plane, providing an additional layer of protection from potential impacts. Another key factor in this situation is the VSK wobbling, named after three researchers, V, Zell, and Kai, who studied how objects move in space. It involves the way three space objects, like Pluto, Neptune, and the Sun, pull on each other with their gravity. This pulling affects how they move. For Pluto, the VSK wobbling helps us understand why its orbit near the Sun is so unusual. Despite Pluto's path appearing erratic, this wobbling helps keep it moving smoothly over long periods. The VSK wobbling shows that even though things in space may seem chaotic and random, some patterns and rules hold everything together. These factors help keep Pluto's orbit stable, ensuring it doesn't collide with Neptune or stray off course. This three-body problem is crucial for understanding how these orbits change due to the way space objects pull on each other. Studying this helps us learn more about Pluto, our nearby solar system, and even distant worlds and their stars. Numerical simulations in the late 1980s revealed that, despite these stable properties, Pluto's orbit is actually turbulent, with minor deviations in initial conditions leading to significant changes over millennia. Nevertheless, these unique properties of Pluto's orbit have been found to maintain stability over incredibly long timescales, preventing the disorder from taking hold. Recent computer tests have helped us understand how the massive planets like Neptune, Jupiter, and Saturn affect Pluto's orbit around the Sun. Neptune has a unique relationship with Pluto, where for every 2 orbits Pluto makes around the Sun, Neptune makes 3. This relationship helps keep Pluto's orbit stable. However, Neptune isn't the only one to focus on. Jupiter's gravity also plays a massive role in safeguarding Pluto's orbit, and Saturn helps as well. These tests show that Jupiter's gravity alone is strong enough to ensure Pluto remains on a stable orbit for a long time, even billions of years. So it's like Neptune, Jupiter, and Saturn are working together to ensure Pluto continues to move safely in space without running into trouble. These quirks are vital in keeping everything stable and predictable in space. Without these forces, the nearby solar system as we know it would be a much more chaotic place, with bodies like Pluto possibly colliding with others or being flung from their stable orbits, causing a cascading effect on other celestial bodies. For Pluto, especially with talks of it potentially crashing into Neptune in the future, understanding its orbit is essential. This provides a clearer picture of the solar system's dynamic nature. The position of Pluto illustrates how even the most seemingly unstable orbits can achieve a state of harmony through the complex exchange of gravitational forces and orbital mechanics. It also highlights the importance of continuous observation and study of these phenomena to better understand our place in the universe. Exploring the depths of space often leads us to confront the unpredictable nature of celestial bodies, and Pluto's orbit is a perfect example of this unpredictability. The concept of orbital chaos, which refers to the delicate dependence of a celestial body's orbit on its initial conditions, is clearly illustrated in the case of Pluto. This means that even slight variations in the dwarf planet's position or speed can drastically alter its long-term orbit. Recreations have been hugely accommodating for analysts in sorting out how Pluto moves in space. These reproductions utilize complex science to mimic how Pluto and other space objects like Neptune pull on each other. By changing little subtleties in the recreations, space experts can perceive how, indeed, even small changes can make a major distinction in where Pluto winds up. In the late 1980s, these recreations showed something intriguing about Pluto's circle. In spite of the fact that it has features like azimuth and scope libration to keep it stable, its circle can still be wild and unpredictable. On the off chance that you start with even a small distinction in where Pluto is or how quickly it's moving, its circle can wind up looking totally different over extensive stretches of time. Yet, even with this confusion, Pluto's circle stays stable for an extraordinarily long time, like billions of years. This implies that Pluto's excursion around the Sun has a kind of order to it, even though it seems tumultuous from the get-go. Anticipating divine occasions, especially when they involve tumultuous circles like Pluto's, is an enormous test. The intrinsic eccentricism of these frameworks means that drawn-out expectations are frequently loaded with uncertainties. While numerical reenactments provide amazing resources to understand and predict the future ways of divine bodies, they also highlight the limitations of our predictive capacities. These models heavily rely upon the accuracy of initial conditions, and any slight misstep or bending can lead to stunningly various results, making exact predictions a staggering task. Besides, the turbulent nature of divine circles like Pluto's reminds us of the ever-changing and dynamic nature of the universe. While we've made tremendous steps in figuring out space, the case of Pluto reminds us how much our knowledge of the universe still remains limited. Understanding the gravitational impacts of the giant planets on Pluto's circle gives significant insights into the broader dynamics of the planetary system. It shows how the presence and position of every planet can make clearing impacts, affecting the stability and direction of other bodies within the system. So why are significant astrophysicists only now raising concerns about a potential collision between Pluto and Neptune, despite all these complex forces attempting to prevent such an event? Neil deGrasse Tyson, a prominent astrophysicist and an essential figure in promoting cosmology, offers a unique perspective on the mysteries of our planetary system, especially the interesting case of Pluto. Tyson, known for his role in the renaming of Pluto from a planet to a dwarf planet, offers sagacious commentary on the evolving nature of celestial mechanics and the public's interest in unexplored realms of space. Tyson's position on Pluto's renaming is rooted in the ever-growing knowledge of our local planetary system. He sees the renaming not as a downgrade, but as a significant adaptation to our developing understanding of the many bodies orbiting our Sun. Tyson's approach to celestial mechanics is one of continual learning and change. He sees the intricacies of orbits like Pluto's as an indication of how much more there is still to discover in space. The appeal of these questions, like the potential for devastating encounters between Pluto and Neptune, continues to captivate not just scientists, but also the public. Tyson's theories about Pluto's possible destiny consider the highly erratic nature of its orbit, making it clear that anything from a close pass to an eventual collision remains within the realm of possibility. Michio Kaku, another famous physicist, lends his voice to the growing concerns about Pluto's destiny. Kaku, known for his work in theoretical physics, dives deep into the mathematics and physics behind the potential interactions of Pluto and Neptune. His theories suggest that while the gravitational effects we've discussed so far offer stability to Pluto's orbit, the long-term future remains uncertain. Kaku warns that as time advances, even the smallest change in the gravitational balance between Pluto, Neptune, and other planets could cause a devastating event. His predictions underline the vulnerability of Pluto's orbit despite its apparent stability today. As we look further into the cosmic components, it's essential to consider the fate of Pluto's orbit. Despite the fact that we've established that the planet's path remains stable for billions of years, nothing in the universe is truly unchanging. Over time, gravitational interactions with other celestial bodies might alter Pluto's direction. The Sun itself will also change gradually, transforming into a red giant and eventually collapsing into a white dwarf. As these shifts occur, the gravitational forces within the solar system will evolve, and objects like Pluto might experience altered orbits. While current models and observations suggest that Pluto's orbit is unlikely to collide with Neptune in the near future, the uncertainty that comes with predicting celestial dynamics over such vast timescales means that we can never completely rule out the possibility. The forces involved in orbital mechanics are powerful and multifaceted, and even small changes can accumulate over long periods, potentially causing major shifts. This ever-present uncertainty in space exploration takes us back to a fundamental aspect of our understanding of the universe. The more we learn, the more we realize how much we still don't know. The study of Pluto and other distant objects continues to push the limits of astronomy, offering new insights into the nature of planetary orbits, gravitational interactions, and the fundamental laws that govern the universe. As astrophysicists continue to observe Pluto and Neptune, new data may emerge that either strengthens or challenges our current understanding. While the possibility of a catastrophic encounter between Pluto and Neptune may seem distant and unlikely, it remains an example of how space is filled with mysteries, some of which are still beyond our full comprehension. Our tools, such as advanced simulations and space exploration missions, are becoming more sophisticated, offering better ways to predict, observe, and understand these grand phenomena. The potential for a collision or near-miss between Pluto and Neptune serves as a reminder of the immense complexity of our local planetary system. These celestial bodies, despite their remote and isolated positions, are not immune to the intricate dance of gravitational forces. Whether such an event will ever occur is uncertain, but the very possibility raises questions about the dynamic and ever-changing nature of our solar system. Ultimately, the story of Pluto's orbit invites us to think beyond the boundaries of our local understanding. It moves us to look at space with an open-minded perspective and embrace the mystery of the unknown. As scientists continue to unravel the secrets of the universe, it's clear that we're only scratching the surface of the many surprises the universe has in store. Whether Pluto and Neptune will remain in their stable orbits or one day experience a monumental clash is a question that only time and further discoveries will answer.